next week to another pair of texts. One of them is called Niels Bohr's Times. It's out in paperback. And the other by Stephen Hawking and Roger Penrose, The Nature of Space and Time. With Niels Bohr and Stephen Hawking and Roger Penrose, we get deeper into the triumph of nuclear physics. You have to be careful and not say nuclear. It's nuclear physics, as in Nukem. One of the great discoveries in nuclear physics is that the language from the past was impossible to use to tell the truth. That the inherited habits of language did not extend beyond the range of a limited wedge of experience. And that as soon as you began to go beyond either to the much smaller or to the much larger, or actually to the much subtler or to the more imminent domains of experience, traditional language fails. Because it is heavily stylized, and its stylization comes from a ritual comportment that was based on an inherited tradition of experience that went back not only hundreds of years, but in its ritual foundations went back thousands of years. But for those who were sensitive and are sensitive to language on one hand and on the other to ranges of human experience that deal with other dimensions of the world, it was apparent that the language stylization of traditional cultural experience description was a small wedge of reality to begin with, and it posed no problem. So that at the same time that you began to find physicists in the early part of the 20th century beginning to question the use of language, there was a concomitant revitalization in fields like painting or poetry or mysticism, which hearkened to this and ran parallel courses. Just recently, in an issue of Nature, the International Journal of Science, from an issue of 2001, just a few weeks ago, the article is entitled Bridge or Ravine: Ideas that cross the border between scientists and non-scientists do not always survive the trip. And it talks about how language lies. Cultural language forms do not commute. And so competing cultures always argue. A civilization is a larger order than a culture, and civilizations were meant to be an form, a form of overview, which would include diverse cultures together, so that when civilizations were first made, civilizations were made on the basis of an urban city form where the cultural languages of the land-based development of people came to a crunch, became mixed together, and in order to prevent them from knotting up into incessant bickering, the interpenetration of cultures was increased through a language transform, so that civilized languages became famous for taking root words from cultures and adding prefixes and suffixes to those roots. And those prefixes and suffixes were extended finally to areas of more sophisticated grammar and of more expressive syntax. So that the development of some languages like Chinese or Sanskrit or ancient Avestic, archaic Greek, those languages are different from folk languages. They are civilized in the sense that they pay attention to grammar and syntax, prefix and suffix, as always modifying the root. So that someone speaking a civilized language is not recognizing on the basis of pointing, but is recognizing on the basis of the gestalt, of the context. And this is extremely important for us to remember here in this education at this particular time. Because we're dealing here with an area where civilizations of the past are being transcended to such a scale that they are like mere cultures compared to the new emerging form that has not yet come through. We know from the past, we know from our long experience that the biggest transform from culture to civilization is ideas. That the transform use of ideas has a developmental phase, an application trajectory, and that it takes about 150 years for an idea to mature. That in the past it took about 150 years. It took about the equivalent of 6 generations to be able to take an idea that one person might have and make it distributed so that it was the common parlance on the streets of the cities of that civilization. History of ideas, about 150 years. And I once, about 25, 30 years ago, looked into the cycles of the application of the further career of ideas, not in terms of the transform from culture to civilization, but with a deeper regard of, is there a cycle where this transformation of an idea from one person to being on the street level of discourse, is there a larger cycle to which that 150 years belongs to? And discovered that there's a periodicity also of about 600 years. That there are 450-year cycles that come together and make a larger set. And there is such a thing as, in an overview of civilizations, a 600-year period also. And getting curious about that 30 years ago, I wanted to investigate, was there any recognition of this fact in what is our classic antiquity? in the Greco-Roman antiquity of about 2,000 years ago, and found, in fact, in the great Roman historian Tacitus, who wrote towards the end of the 1st century AD, about 1900 years ago, that he mentions the cycle of the phoenix, and that the cycle of the phoenix was every 500 years. And that in terms of civilization patterning itself, 2,000 years ago, the men and women who were really deeply cognizant that something was happening in their time which had happened before, and that not paying attention to ideas, because ideas were not as important transforms 2,000 years ago as they have been in the past 2,000 years. But that the cycle of 500 years was very important to them. And it was very close to the cycle of 600 years, which I had teased out of the material and the evidence. And Tacitus says that these cycles of the phoenix every 500 years are an Egyptian way of recognizing cyclicity, not only cyclicity but periodicity in history, that history is a medium, and that in this medium there is a reoccurring periodicity of 500-year cycles, and that if you look at the ancient Egyptian way of computing this, 4 cycles of the phoenix constituted, and they use the Greek term, not the Egyptian term. The Greek term is aeon. The Greek spelling is A-I-O-N. The Latin spelling that comes down is E-O-N, eon, aeon. Sometimes it's A-E-O-N. So that 4 cycles of the 500-year phoenix was a double millennium, and that was an aeon, and that was a time periodicity for civilizations recognized not just 2,000 years ago, but was recognized 4,000 years ago. That the idea of an aeon came in about 2000 BC, a little bit before. And that the locus of this idea of timekeeping like this, in fact, was imported into Egypt at that time in 2000 BC and was not an Egyptian original idea at all, but originated in ancient Iran. But in an Iran that was not located in historical Iran today, but was located in the Central Asian extension, which today is Uzbekistan. And that the idea of an aeon was a repeating time form that always occurred when certain conditions obtained, and that the conditions obtaining that made it trustworthy that time was going to run in these cycles was that existence is polarized. So that around 2000 BC, the idea of a polarization into a duality of matter constituted the archetypal condition for time gaining a periodicity which could be predicted. And out of that 2000 BC confidence that this was so, one of the large subsets of the civilization of that time, called the Babylonian people, developed astrology to try to find it must be a pattern of predictability to historical events, and that will reoccur. And thus, out of it came a very profound idea that if you take a cycle, like an astrological cycle of the zodiac, and you repeat on many levels that same periodicity into subsets and subsets and subsets that you acquire through this repetition, a process known in mathematics in the 20th century as iteration. That if you repeatedly iterate a pattern on more and more refined subsets, all within the same resonant order, that you can come extraordinarily close to predictive, proscriptive events. And you can tell not only what will happen, it will be what will happen in a non-prophetic way, but in a prediction way. And so astrology was not a prophetic mood or science. It had nothing to do with prophecy. It had everything to do with repeated iteration. And we know today in mathematics that repeated iteration is one technique of coming closer and closer to the actual probability of something. And while one scale will give you a fairly good probability in mathematics, on level of astrophysics, a repeated iteration will get you closer and closer so that the probability of error is minuscule and almost non-existent. Before that historical development gained ground 4,000 years ago and became one of the constituents of civilization, the confidence was in a different comportment, not one of chance and probability and repeated iteration, but one of change and uniqueness and of mysterious, infinite inclusiveness. So that one of the examples of a pre-2000 BC way of understanding without probability, of understanding change and not chance, is the I Ching, the Chinese I Ching, the original I Ching, which goes back to at least 3000 BC, and is characteristic not of civilization, but is characteristic of what today we would recognize as the tail end of Paleolithic wisdom. That Paleolithic wisdom understood in terms of change and not chance, understood in terms of Tao and not Te, that the basis of understanding was on the basis of modulations of zeroness, whereas civilization has always preferred modulations on the basis of unity. So that one of the first things civilized people do is teach their children to count. And that counting has a linear quality, and that linear quality always assumes the character of what in physics is known as a plane wave, P-L-A-N-E, plane wave. And that, oddly enough, that entire confidence is fully justified as long as you limit what you're doing to that particular wedge of experience and understanding. But that in reality, energy could have assumed any kind of a form, not just that of a plane wave. And so it is a peculiar thing at the beginning of the 21st century. In order to be really educated, one has to be ready for the final surprise. And that is that all of our learning is a closed box example of assumption that may be very minuscule in the universe. That everything that we know and believe and trust and have confidence in is perfectly fine as long as we stay in our sandbox. And that outside of it, the unknown stretches everywhere, all the time, without boundary. So that an education like this is not an instruction in subjects about what we know, but is a preparation for surprise of learning how to learn. 300 years ago, a man in England, tremendous intellect, his name was John Locke, L-O-C-K-E. He wrote an essay on human understanding. And it was one of the foundations upon which Newton joined forces, and it made the whole notion of an enlightened form of Western civilization. And we today still have political forms that are based on that confidence. But about 30 years ago, an Englishman named Stephen Toulmin, T-O-U-L-M-I-N, he and his wife, June Goodfield, had been commissioned by a British corporation, a corporation made to make gifts of money to certain projects to see that they would come to fruition, the Nuffield Foundation from the Midlands of industrial England. And the Nuffield Foundation wanted to have a series of short films made to teach children science. And so Stephen Toulmin and his wife, June Goodfield, worked on about 5 or 6 of these films, and then they made mature books. One of them is called The Discovery of Time. And they're films to teach children about astronomy, chemistry, physics, biology, mathematics. And Toulmin, in doing this, found that he constantly came against his own limitations, his own assumptions. And in trying to cough up this furball of wondering, what am I doing that always gets in my own way, he wrote a classic little book called The Uses of Argument, published by Cambridge University Press, one of the great little primers on logical exercise in the world. And then he came to the United States, and he was hired away from the University of Chicago, and he was set up at the University of California in Santa Cruz when they started their History of Consciousness program in the 60s. And Toulmin realized that what bothered him was John Locke's essay on human understanding. He finally focused, and he realized that this preconceptive foundation limited our ability to learn. It reinforced our confidence in that checking out what other people knew, we could then know what they knew, and we were then learned. And that all of this was fictive. And so he began a process of trying to rewrite Locke's essay on human understanding. And he got as far as writing the first volume, and he couldn't get any further. And the first volume, volume 1, was published by Princeton University Press about 1966. And we waited for years and finally decades for further volumes. They're not coming. But he says in the introduction to his new essays on human understanding, we have got to get over the preconception, the habitual addiction, that we know something when we can fit it into categorical egg crate places. He said a true test of rationality is the ability to start from scratch and address the unknown and to build a meaningful relationship of mobility and industry and design vis-a-vis the unknown from scratch. And that's what rationality really is in a real way for us. One of the reasons for not completing the volumes is that at the time when John Locke wrote an essay on human understanding, there was a man who had an even bigger IQ than him, who saw the complete bogus limitations of Locke's work. And so he wrote in his time, 300 years ago, a book that almost nobody read at the time. It lay untranslated for, 200 years. It lay on the musty shelves of a library in Hanover, Germany. It's a long story. The last patron of Leibniz, the man who wrote the book, was the man who became the first George I, King of England, but he was German. The House of Hanover went over to England, and it was a tandem thing that was planned for generations to bring at that time the royal houses of all of Europe together into a new form. Only the tutor of George I, who really understood what all this was about, was left behind in a dusty library in Hanover, Germany, so that he wouldn't keep on with his incessant educating of the women of the household. Because George I didn't like the fact that his wife, Sophie, and his daughters were becoming so incredibly alert and smart that they were seeing through him and his limitations and shenanigans all the time. And that he became fearful that if all of the women became this alert, life was going to be very complex. And so he left this prize historical super teacher in this dusty library, and it was there that Leibniz wrote his monumental new essays on human understanding. And when it was finally done in a new edition and translated in a new presentation by Cambridge University Press in the late 1970s, it became a cause célèbre in philosophic circles. One of the things that Leibniz had working for him is that when he was a young man, when he was 19, 20 years of age, he was the first European to be exposed to the I Ching. He just happened to be, in his travels as a young man, in a very peculiar place at the time. This was the 1660s. He was in Amsterdam. And he was in conversation with one of the most philosophically sophisticated Jewish mystics of all time, a man named Baruch Spinoza. And Spinoza told the young Leibniz that he understood some of the implications of what Leibniz was talking about in terms of mathematical ideas, because they were not European, they were Chinese. And Leibniz said, what do you mean Chinese? And Spinoza said, I have just talked to some Jesuits who have translated an ancient Chinese wisdom book into fairly passable Latin, which you can read, and it's called the I Ching, the Book of Changes, and it's all about change. And that Leibniz, as a young man, understood that there is such a thing as a profound mathematic to change, that one does not have to deal with probabilities on the basis of unity alone, but you can deal on change which has not only chance, but change itself. The one for probability base and the zero for change base. And that there are transforms that function on a zero base, even though they're not existentially detectable. They still function. Just like there are transforms that function on fractal or fraction basis of unity, or multiples of unity. So that there became, at the time, when Leibniz was mature, took Locke to task, wrote this monumental book, and Tolman, in writing his first volume, came very close to following in the broad vectored path that Leibniz has set out some 300 years before. And then Tolman recognized that, in fact, what comes out of this is not a philosophical stance, but the development of a mathematical practice that we know today as calculus. And that it wasn't just Newton and Leibniz who developed this mathematical technique, but it was specifically Leibniz's language, his notation of the changes between 1 and infinity, 0 and infinity, 0 and 1, the infinite, and that when you put 1 not just in the middle of 0 and infinity, but that you have an infinite approach to 1 from both sides going both ways, that his notation dealt with the fact that human reason, human ratione, the rational aspect, could be so precise that you could deal with infinite exactitude of everything in between to whatever degree of specification was necessary. It was 300 years ago. And we today use a notation based on Leibniz and not on Newton. Newton, because of his alchemical disposition of using a language that was based on traditional mystery chemistry, liked to call them fluxions. And for a long time in English, the word fluxions was used. There is such a thing as an integral calculus and a differential calculus. And there are differential equations and there are integral equations. But there are also integral differential equations that bring them both together. And one of our figures that we're taking, Richard Feynman, is one of those figures who brought together the way in which both aspects, the tau and the te, do work together, not just in a unity. The word unity lies. They work together in a reality. And that reality makes unity but one part of the set of expressiveness. One of the great misconceptions of the later part of the 20th century is to identify yin and yang with tau and te. And because of yin and yang being positive and negative in an analog sense, of being masculine and feminine in an analog sense, that there was a tremendous confusion about what Tao, that there could be such a thing as the Tao of business, the Tao of legislation, the Tao of litigation, who knows? And this corruption of that kind of term has beggared it so that it's almost impossible for anyone to speak English today and use the word Tao. But the original understanding in the Chinese goes back before civilization. It goes back to pre-dynastic China when there was still a Paleolithic wisdom alive and well. And Fu Shi always was a part of a set that included not just himself, but included his pair, Nu Gua. And Nu Gua, she was extraordinary because, in a way, Fu Shi and Nu Gua together allowed for an interpenetration in a paired set of the way in which reiterated measurement brings one closer and closer not to actuality, but to a threshold of insight. So that while you get closer and closer in terms of probability of accuracy, that probability of accuracy doesn't achieve exact rightness, but achieves a threshold beyond which there is a mysterious gestalt of the reality, and that one understands, but it isn't that one understands something, but that one understands understanding. And it isn't something that's graspable, but it's the very choreography that involves the motion of the hand to grasp in the first place. That the context is always a part of what is real. So that when physicists use a Max Planck Einsteinian equation saying that E equals hv, energy equals the Max Planck constant h times v, the momentum, energy, velocity of a polarized particle, it always assumes the character of a plane wave. Not that that is real, but that under those conditions and assumptions, that's what in fact happens. And that you can count on that happening any time that you're working within that particular sandbox. It will always happen that way. But to make the mistake of identifying that with reality is actually a sign of very poor education. So that the whole notion of causality, which was very big in Locke's day, and the ability to be specific and ingenious and subtle about causes and prescriptive quotations that exactly exemplified the causal delicacies of things, came to rest in someone like Samuel Johnson, the good Dr. Johnson, who had precise, well-heeled comments about all kinds of human behavior, and they were written down by his amanuensis James Boswell, and Samuel Johnson became the prototype of the English savant who knew precisely why you were wrong. But the peculiar thing about causality, we today, in the early part of the 20th century, would be embarrassed to even talk about causes. That the kind of language that harkens back to Paleolithic wisdom and refreshes the English that we're using, so that now we might talk, instead of about causality, we might talk about a cascade. That, as we talked last week, if you're alert on level of split-second attentiveness, you can see that there is a kind of a hidden staccato of micro-movements that constitute movement in the first place. One of the great examples of this is a magician who does sleight of hand, legerdemain. He can learn to move his hands and objects in a very special periodicity that's not noticeable to the ordinary untutored human eye, so that you do not see that woven into the movements that you do see are movements you cannot see because you've not learned to see those kinds of movements in their periodicity. And he can do all sorts of things underneath the movements that you're seeing and watching, and can make things appear seemingly out of nowhere. They do not appear out of nowhere. They emerge out of another kind of periodicity, a different kind of time, a magic time. And that they also have their periodicity. And one can learn to do this. I remember at 80 years of age, Manly Hall doing a special magic show for my 5-year-old daughter at the time, and he could still make those rings that were solid link together and make chains all in just a split second, and then take them apart, and you would try, and those rings were solid. There was no way to do that. once you have the feel of it, it's not a matter of doing it by the eye. A magician doesn't work by the eye. He works by the hand movement, which is a version of the dance. That Paleolithic wisdom's periodicity is in terms of posture and movement, exemplified by dance and fortified by song or chant. And that chant has a different kind of logic from abstract discursive causality. It doesn't go by rules. It doesn't need rules because it occurs all at once, because it's on a 0 index and not on a 1 index. Because Tao is about change, so that seeming nothing has something emerge from it. And its emergence is always whole. It's never partial. So that whenever the mind, in its time, space, language, truncated predisposition, looks at energy in a measured way, it becomes a particle. And it's not because it's a particle in reality. It's because its reality is that when it's looked at in this way, it will be a particle every goddamn time. And if you look away, it isn't a particle anymore. Let's take a break. They never tell you it's radioactive. That's why all the insulation. Cascades. Energy, when energy is polarized, that is confined, in conditionals, it becomes particles. So Feynman in QED, Strange Theory of Light and Matter, one of our books, one of our pairs of texts, on page 15, I want to emphasize that light comes in this form. Particles. It is very important to know that light behaves like particles, especially for those of you who have gone to school, where you were probably told something about light behaving like waves. I'm telling you the way it does behave, like particles. You might say that it's just the photomultiplier that detects light as particles, but no. Every instrument that has been designed to be sensitive enough to detect weak light has always ended up discovering the same thing. Light is made of particles. So sometimes particle physics. And the tradition in civilization is to carry the metaphor that light determines what is real. And this is not true. Not true at all. Nothing determines reality. If it's determinable, it has already slipped into a subset of Te. And can transform within that subset, sometimes by what seems to have a causal relationship, but very often, if you want to transform the entirety of that condition, you can by bringing in a zero-based operator. The difficulty when you do that mathematically is that you end up with infinite possibilities. And most of our 20th century science was finding ways to renormalize out of the infinities and get back to where you can determine and measure. And we can do that. But like the problem the Victorian English faced with Maxwell's equations for electromagnetic energy, those equations not only solve in the positive, they also solve equally well in the negative. That you can have negative energy universes as well, and they work very well. And it turns out that you can also have higher order in terms of vibration, even in the electromagnetic universe. That the electromagnetic universe has its range of frequencies, the electromagnetic spectrum. But that, as the words themselves disclose, it is not a spectrum of electromagnetism, but it is electromagnetic. It has an electrical component and a magnetic component, like the yin-yang. And that it also has its complement of a magnetoelectric spectrum. And magnetoelectric energy is about 10 billion times the energy of electromagnetism. So that you could have a form that was existential in terms of magnetoelectric energy that could walk through this universe as if it didn't exist. That there's more space between atoms and nuclei and electrons, so that it would be like walking through a phantom dream. And if you had a teacher made out of magnetoelectric materia, you wouldn't even know that they're there. But they would have an effect. So that there is a magical cosmos that really exists, and one doesn't even have to get to the zero complement to the set. That it already is there just on level of what we would or used to call physicality. So that our education, when we come to science, we're not just sensitizing ourselves to an enormous range, but we're sensitizing ourselves that all of these enormous ranges have an enormous array of orders available to them. And that what permeates all of this is the ability to transform. That forms are always provisional and that they can change. So there is such a phrase that even has become a shibboleth by now: all things change. The formulation 2,500 years ago by the historical Buddha was that all contingent things discontinue. They all, because they have an initial point, they have a beginning, they also have an ending. It's not that reality ends, but whenever there is an initial condition, that becomes part of a set of conditions which determine, which allow us to recognize and work with, to manipulate, to fashion boundaries. And boundaries are extremely important, boundary conditions. So if you come to something like this was published in the very year that Sputnik went up, and at the time was extremely avant-garde. It's called Neutron Transport Theory by B. Davison. And Davison was the big honcho in the physics department at the University of Toronto. And in fact, the book, though it was published in 1957, was originated 10 years before in 1947, and it was then called Transport Theory of Neutrons, Transport Theory of Neutrons, and it was published by the National Research Council of Canada, the Atomic Energy Project, document LT18, which means it's very early, 1947, because it was extremely important in 1947 and very hush-hush. You couldn't have gotten a copy without a security clearance. By 1957, just 10 years later, if you knew what it was and had the bucks, you could buy this Oxford University Press book and get to some very interesting situations. On pages 20 through 22, a discussion in math, but nevertheless discursively available for at least a glimpse. It's chapter 2 and it's section 3, and it's bold-faced, the boundary conditions. And they use an equation that appeared in chapter 2, and the equation is number 2.4, and it reads, the equation, 2.4, is an integral dash differential equation. And to make the problem of its solution determinate, it is necessary to specify boundary conditions. Because if you do not specify, that is, if you do not project out the assumptions that you're working with, there is no way to determine. It's not determinate at all, because there are no boundaries. So that the boundary conditions are, in the ultimate level, unassignable, not through a label, but through the specifications that constitute together boundary conditions, and that allows for us to be infinitely exacting as to determination. The equation is an integral differential equation, and to make the problem of its solution determinate, it is necessary to specify boundary conditions. These, in fact, follow at once from the physical interpretation of, and then there's a mathematical expression. We shall limit ourselves at present to showing how they are formulated in some illustrative cases. And then there's a series of 4 subsections which together constitute a matrix of concerns for boundary conditions, at least in this fairly early level. You have to realize that even by 1957 is still very early. It's very early still. 4 elements in the matrix of boundary conditions. 1, the interface between 2 media. If 2 media are in direct contact, that is, without any other matter interposed between them, then any packet of neutrons characterized, and then they give you 2 vectors, will contain exactly the same number of neutrons when it enters one medium as when it left the other. And this turns out to be an enormously powerful insight. And the first person to have this insight was Robert Oppenheimer in January of 1939, the end of January. And I'll tell you about that in a moment. The second of the 4 elements, the first is the interface between 2 media. It's one of the boundary conditions. The next is the free surface of a medium. The free surface means that in transport theory, to denote a surface or any part of one on which no neutrons fall from outside, completely enclosed in the continuity of that material. The third is the condition at infinity, and the fourth is the initial conditions. Now, if you have these 4 in this matrix, one can constitute boundary conditions. It's interesting. The book is called Neutron Transport Theory, and it involves the way in which atomic energy, atomic bombs, nuclear science, all of it was developed. And the scary thing was how close the Nazis came to developing it before anybody else. The first time that someone used neutrons to bombard another material was by a very famous, lovely individual named Enrico Fermi. He did it in 1934, but his research assistant was a woman, and when she said that she got out of the math that the nucleus of the material had split into smaller fragments, her discovery was discounted. No one paid any attention to it. It was in 1934, and Fermi himself didn't see it. She was the only one who could have seen it. Her name appears in John Wheeler's book, has a very strange name, Gaions, Black Holes, and Quantum Foam. Her first name was Ida. The next time that neutrons were used to bombard a heavy material, uranium, the highest on the level of the 92 naturally occurring elements, was in a Nazi lab in Berlin. Otto Hahn and Fritz Strassermann. And they didn't know what they had. And one of the men, younger men, who was privileged to the experiments, the information, his name was Otto Frisch, not particularly a Nazi at all. In fact, he was silent about what he saw because he didn't understand it either, and he was given leave to go and visit his aunt, who was living in Sweden because she didn't like the Nazis at all, and his aunt was one of the world's greatest physicists, Lisa Meitner. And in walking on a winter's evening, he was on skis, and his aunt, Lisa Meitner, was not athletic. She was walking while he was cross-country skiing, and they were talking about what they'd seen. And Lisa Meitner, again, another woman, had the insight that what had happened was fission, that they had not recognized the Nazis in their lab, that they had created a minute fission of material. And she was in communication with Niels Bohr. And as soon as Niels Bohr heard what the experiment had done with neutron bombardment of uranium, Bohr, being someone who knew about Tao Te, he'd put the Tao Te Ching emblem, symbol, on his family crest long before. As soon as he heard, he understood. And his comment was, of course, it's obvious, it's obvious, it's obvious. Immediately was in contact with the Americans. And they arranged an invitation in early January 1939 of Niels Bohr to come to the United States and deliver a lecture at Princeton. Why at Princeton? Because Princeton had developed a special institute of advanced studies to house one man, Albert Einstein. And they knew that maybe the only two people in the world who could talk on this kind of a depth of Tao Te were Einstein and Niels Bohr. And so in January of 1939, Bohr came to New York. Wheeler was sent from Princeton to go and meet him, and when he was there, he recognized Enrico Fermi was there with his lovely wife, Laura. Fermi had just the month before received the Nobel Prize for Physics in Stockholm, and because his wife was Jewish, he just conveniently didn't go back to fascist Italy. He went to Columbia, where immediately an advanced position was made for him in the physics department, and the University of Chicago the next year would take Fermi, and out of that came the Fermi Lab and all of the developments. Bohr didn't tell Fermi right away because he was saving the information for a special occasion. He wanted everyone to know, on one hand, that it was Lise Meitner who had first conceived that this was fission and that we had cracked atomic energy. But his amanuensis, a man named Leon Rosenfeld, when Fermi and his wife Laura convinced Bohr to stay and spend a day in New York with them, on the train back to Princeton, Wheeler invited Leon Rosenfeld to talk that evening to an informal Monday evening group of the physicists. And it was there that the world first learned that nuclear fission was possible, that in fact it had been done in a lab, and if the math checked out, we were on a whole new threshold of possibility. And within 2 weeks, that information, that discovery reached Berkeley, California. The head there was Luis Alvarez, but the star intellect there, even though Alvarez won a Nobel Prize for physics later on, the star intellect there was Robert Oppenheimer. And like Einstein and Bohr, as soon as he heard that you could have fission for a uranium nucleus, he saw immediately that you could have that fission because of neutron transport having a commutable distributive evenness. You could have it continue in a chain reaction. And so Robert Oppenheimer was the first person on the planet to understand immediately this meant not only fission of an atom, but fission of atoms as far as you want, a chain reaction resulting in enormous energy release. This was in January 1939. That spring was a crucial time. Most physicists, like Wheeler, saw it only as a research into nature. But there were figures like Bohr and Fermi and Oppenheimer and Einstein who understood really deeply that this was a catastrophic change in the scale of human technology, and that it applied directly and very quickly to the development of things like political order, of the development of history of man on the planet, to everything. And they were filled with trepidation of whether to make clear to those in charge of decisions of world political forms to let them know what had been done. And they were forced by circumstance, because one of the great geniuses working on the Nazi side was Werner Heisenberg, who understood math well enough that as soon as he would begin to get the information, that they would go for development of an atomic bomb. And so the material was presented to the best mind on the planet in terms of historical development of political forms, and that was Franklin D. Roosevelt. And Roosevelt understood that it was perhaps the deepest crisis in human history since the discovery of fire. And so the quality of being forced, once that threshold had been pioneered, of being forced to continue the exploration and the development, to bring that insight, that idea into a technological fruition. And in 1943, Los Alamos was set up to be the place where all of this was put together. And when Wheeler suggested to Oppenheimer that Richard Feynman be brought in. He was brought in largely as a mathematician, as a young, brilliant mathematician. And his genius was to be able to understand how transform operators give us a way of following the clues of what happens in subatomic cascades where chance and change operate as a set together even deeper than just boundary conditions, and that there has to be a way in which one could express this so as to be worked with on technological level. Out of his work in the next 5 years, Feynman, though he was a genius in terms of physics, he was studying with Wheeler as a graduate at Princeton. He had graduated from MIT. He was later on a professor at Cornell, and then finally went and became the great professor at Caltech. But he did not have confidence in the traditional understanding from mathematics courses of how to do higher level physics. And so in order to check himself that he was understanding realistically, he began to make his own diagrams. He developed his own language, his own syntax, his own grammar of diagrams, and they are known today as Feynman Diagrams. And they're used all over the world because they express in an original language made to express them this taute delicate nuance of the real and not the mental. Now, it's very similar. It's very similar to the way in which the Tibetan language that was developed in the original form. When the Mahayana went into Tibet the first time in the 700s AD, it went in under the aegis of a very great magician. His name was Padmasambhava. And his way of delivering his teachings was to use magic, a kind of a high Dharma legerdemain. And he used a paired set of male and female, only he presented two versions of it. One was with his pair, his mate, his consort named Yeshe Tsogyal, means sky dancer. And Padmasambhava with sky dancer presented the Tao, whereas Padmasambhava with a princess named Mandaravna, they presented the Te, something related to the Tao in a set of the real, but something that led to determinateness, led to measurable quantities of limited ritual, ceremonial, mental actions that could be cognized in a measurable way. Whereas Padmasambhava vis-a-vis Yeshe Tsogyal dealt with infinities all the time and never renormalized anything. So that the original Vajrayana was in such an esoteric, subtle, paired way that it was almost impossible for anyone to learn. No one was smart enough, no one was nuanced enough to learn. And so Padmasambhava wrote out detailed, step-by-step ways of acquiring not only this knowledge vis-a-vis Princess Mandaravna, but these powers vis-a-vis Yeshe Tsogyal. And then buried these esoteric texts all over Tibet to be found in a future time sequence history When people had matured to the level where they could understand them, then they would be found, and these hidden things are called terma, hidden texts. After about 300 years of this kind of spotty, peculiar occult development, that tradition is known as the Black Hats, the Nyingma, the old school. A completely different take on it was because of a complete revolution in the Mahayana. And out of the Indian yogic tradition came a different quality of talking, a different use of language. And the person in India who was responsible for bringing that all together, his name was Atisa, about 1000, 1050 AD. And Atisa understood that there was a way of speaking originally so that one would not fall into the impasse of assumed grammars, of expected syntaxes, and of habitual vocabularies. But it was very difficult to master because you had to be completely disenchanted with the confidence that you could say anything meaningful. And so you had to have the ability to have instantaneous language spontaneously come out of complete silence. And the first person to master that was Milarepa. His 100,000 songs of Milarepa are like David's psalms, like King David in ancient times. They are psalms that come out of a fullness of not knowing. Like King David's psalms, the ones that are originally his are often called in Jewish tradition the royal psalms. They're the songs of the king, and they are not sung for man to understand. They're sung for man to praise God in God's way. And if man can't understand them, that's because of his limitations. God doesn't have those limitations. And the way one knows that those songs were heard is that the kingdom is blessed. You see the results. You don't know how it happened or when. And out of that comes the esoteric Jewish, ancient Jewish idea of charity, that the highest charity belongs to God and not to man. And therefore, the highest charity, no one knows who gave and no one knows who received, and no one knows how it happened. Thus, the open chair, the open seat at a Seder. It's for the unknown to occur or not occur as it will. World without end. When it came to Feynman developing a language, he chose a similar path to the way in which post-Atisa, post-Milarepa, Tibetan language was made. It was formulated. It was formulated to speak high Dharma. It was not formulated to have a peasant root. It was not formulated to have any kind of traditional cultural reference. It was made to express high Dharma paradoxes from the get-go, so that Tibetan vocabulary and grammar and syntax don't work in a pedestrian way very well. But as soon as it takes off and gets its landing wheels tucked in, and you get into Mach 20, the Vajrayana syntax and grammar and vocabulary of Tibetan becomes truly magical, so that one can say the unsayable in normal cultural folk-based language. Could never say it, and in Tibetan you can say it. Feynman's diagrams are like that. They're like Vajrayana, high Dharma language meant to say, not please pass the sugar, but why it is that the molecular structure of sugars interfaces on the atomic level with the way in which proteins key in maybe digestive juices. And one can say this. By the way, the first chemist to really understand quantum mechanics applied to chemistry was Linus Pauling. As early as 1935, he wrote a huge textbook on the chemical applications of quantum mechanics. By the third edition, it was the standard text in the world. When we come to a book like this, published 1994, Diagrammatica, The Path to Feynman Diagrams, Cambridge Lecture Notes in Physics. Page 15, the second chapter. No math, don't worry. There's only one equation. We can take care of that. It's called Relativistic Quantum Mechanics of Free Particles. It's labeled Hilbert space. It's named for a very, very great mathematician named David Hilbert. David Hilbert, very quiet, well-trimmed, bearded, usually with a hat, kind of like a pipe. And David Hilbert wrote a classic called Geometry and Imagination that's still in print. And also developed what is known today as Hilbert space. Not the ordinary space of culture, ritual, tradition, it's here, but a different kind of space because there are many kinds of space, just like there are many kinds of time. And that when you add the dimension of consciousness, it goes into infinite kinds of spaces, infinite time periodicities. One can iterate in such a slow way that it only happens once and yet is an iteration. You can even slow it to absolute nothingness so that it never happens, and that is also an iterable non-actuality. That's falling off the deep end. You can get in trouble if you do that out on the street. In a quantum mechanical description of a state of free, spinless particle, the state of a free, spinless particle is completely specified by its three momentum. The energy follows from the energy-momentum relation. E equals mc squared. Location in space and time under this is completely unknown. Yeah, it reads that. The energy follows from the energy-momentum relation. Location in space and time is completely unknown. It's not that it's unknown now and later will become known. Under these boundary conditions, it is unknown. It's not an unknown quantity. It is not within the possibility even of designating to it unknown. It is disjunctively not known. Its not knownness never is known. It sounds like a poem by Kandinsky. What? And he said, blue rose and fell, and a white so sharp that it pierced through like a horn of a rhino. Can you imagine? I'm reading from this physics study here. Location in space and time is completely unknown. Of course, we could also specify location, and then they give us a small x with an arrow over it. It gives us an x-coordinate dimension. Of course, we could also specify location x superscript arrow, but then the momentum would be unknown. As soon as locality, even in one dimension of space, like a vector, is specified, then the momentum is unknown. Not unknowable, it's unknown. But first, and he leaves it there, the author leaves it there, Veltman. He says, but first, we concentrate on the momentum description. Also, we will start with a particle of which only one type exists, unlike the photon or a massive photon. There are many states for light as particles. One type of particle exists unlike the photon or a massive photon. Such particles are called scalars or pseudoscalars, depending on the behavior of the wave function under reflection. The pi superscript 0 is an example of such a particle. It is a pseudoscalar. Let us pause a moment to reflect on the physics of the above statements. In conventional presentations of quantum mechanics, one encounters a postulate. It's like in any kind of geometricity, you have axioms that you begin with, and you have postulates that you continue to construct. There's a postulate prescribing the commutation relation between momentum and location operators. The commutation relation between momentum and operational location operators. The essential physical content of that mathematical statement is this: a particle is well-defined, with well-defined momentum and, of course, energy, is described by a plane wave. A plane wave. This is the true content of the Planck-Einstein relation, and then they give the formula E equals hv. V is the velocity, h is the Planck constant, E is energy. It could have been different. Yeah. It could have been different. That's all the words in that sentence. It's not mysticism. It's physics. It's Feynman diagram physics. A particle of well-defined energy could have corresponded to some other wave. What other wave? The possibilities are endless. For us, energy works in this way and always has, and everything on this planet and the star system, everything as far as we can see does, but in mathematics it's very clear. There's lots of ways that it can work that we can't even imagine. They are not imaginable, and yet they're real. So what are you worried about? You may be saved and never know. But this is the idea. A particle of well-defined energy is a plane wave with frequency v. Thus, we do not postulate commutation rules, but we postulate that a particle of well-defined momentum and energy is described by a plane wave. He's saying with Feynman diagrams, we're not worried about the rules, the syntactical, grammatical, logical rules of mental measured discourse in tradition. As far as you can see, all that is fine. That's not what we're doing. We're working with what really obtains for us, not only in the laboratories, the cyclotrons, the bevatrons, the tevatron coming up, but also in the math. And that we can use this different high dharma language of Feynman's diagrams and communicate with each other without getting into worrying about the rules that we thought were necessary. We were told rules are necessary for thought to happen, but what we're dealing with is not thought. We're dealing with consciousness. which doesn't have any rules at all, but a lot of magic. Please get a hold of The Nature of Space and Time by Hawking and Penrose and Niels Bohr's Times. And we'll start next week and see how this goes even more mysterious.